limit definition is definitely a little tricky. Hopefully you start to pick up on the patterns as we go along with it. Where we're going to start is with finding the slope of the tangent line, which is really what the derivative process does. Here we're given a point and an original function. We're going to use a slightly different formula here than we do when we're just doing it for generic x's. So here what we're going to say is we're looking for the limit as delta x approaches 0 of f of the point that we're starting at, which is x equals 3, plus some delta x minus f of 3 divided by that same delta x. So we're going to first plug in 3 plus delta x everywhere we see an x. That's going to give us 2/3 3 plus delta x minus 2. And then we're going to subtract from that f of 3, which is 2/3 3 minus 2. So, sorry, 2/3 3 minus 2, but we're subtracting the whole thing. All over delta x, and really I should keep this limit as delta x approaches 0. So my next step, this 2/3 times this 3 becomes a positive 2. Positive 2 and negative 2 cancel. This 2/3 times this 3 becomes a positive 2. Positive 2 and negative 2 cancel. So it's really 0 from this, 0 from this. The only thing that remains is this 2/3 times this delta x. So it becomes the limit as delta x approaches 0 of 2/3 times delta x, so 2/3 delta x, over this delta x on bottom. We're always hoping that we get to a point where delta x can be isolated on top and bottom and reduce and leave the problem, which can happen here. And we're left with the limit as delta x approaches 0 of just 2/3, which equals 2/3. It's like when we plug in a constant limit. If the limit of f of x, where f of x always equals 3, then it's going to be 3 no matter what. This is telling us no matter what delta x is, it's really always 2/3. So specifically at this point 3, we got back and found that 2/3 was the slope of that tangent line. Using the derivative process here, we're instead of plugging in a number, going to just plug in a generic x. So when we have f of x equals 2, we're finding the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. So if we put in x plus delta x to this formula, we just get 2. If we put in f of x, we also just get 2. So this becomes 2 minus 2 over delta x, limit as delta x approaches 0. This gives us limit as delta x approaches 0 of 0 over delta x. If delta x is very small, but still something real, which is the idea of it approaching 0, 0 over anything real is going to give you 0. So this final answer tells me that 0 is the derivative of f of x equals 2. This will be true for any constant. When you start with a constant function, its derivative is 0. This one asks us to start with f of x equals 4x minus 7. So we set up the limit as delta x approaches 0 of f of x plus delta x, which becomes 4x plus delta x minus 7, and then subtract the whole thing, 4x minus 7, all of it over delta x. That equals the limit as delta x approaches 0. On top, 4 times x gives me 4x. 4 times delta x gives me plus 4 delta x. Minus 7. Distribute the negative. Negative times the 4x is negative 4x. Distribute the negative times the negative 7 is positive 7. All still over delta x. This 4x and this negative 4x are equal and opposite. This negative 7 and this positive 7 are equal and opposite. So I'm left with positive 4 delta x over delta x. I can reduce by delta x and just get my final answer, which is 4. There's nowhere to plug in the delta x once it reduces, so I just get that answer of 4. Number 4, we start out with f of x equals 2x squared plus 1. So we set up our limit definition. The limit as delta x approaches 0 of f of x plus delta x becomes 2x plus delta x squared plus 1 minus 2x squared plus 1 all over delta x. When I square this out, I use my FOIL method. So the FOIL method tells me that I have x times x, which gives me x squared, x times delta x, which gives me 1 delta x, x times delta x again, which gives me 2 delta x's, and then delta x times delta x, which gives me delta x squared. That's why I get 2 times x squared plus 2x delta x plus delta x squared, all of this plus 1 minus 2x squared minus 1 all over delta x, and still limit as delta x approaches 0. When I multiply out this 2, this becomes a positive 2x squared, which reduces with that negative 2x squared. This positive 1 and this negative 1 also reduce. What's left behind is this times this 2x delta x. So I have the limit as delta x approaches 0 of 2 times 2 gives me 4x delta x. And then 2 times delta x squared gives me plus 2 delta x squared all over delta x. I can reduce everything here by a delta x. So that means that this delta x and this delta x cancel and leave me with 4x. This delta x reduces by a delta x and leaves me with 2 delta x behind. So it becomes the limit as delta x approaches 0 of 4x plus 2 delta x. This is the first time in one of these that we've had this delta x still in the problem before we've completed doing the limit. So we should do substitution here where we plug in a 0 and where we see delta x. It becomes 4x plus 2 times 0, which is just 4x. So my original equation, 2x squared plus 1, the limit definition of the derivative got us to the end of the process with this answer, 4x. We're going to do the process now for x cubed minus x. So it's the limit as delta x approaches 0 of x plus delta x to the third power minus x plus delta x minus x cubed minus x all over delta x. That becomes the limit as delta x approaches 0. When I cube something out, I use the Pythagorean Triangle, I guess you would call it. Maybe it's not called the Pythagorean Triangle. It's the thing where you line up and it starts 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Hopefully you guys have seen this before at some point, but basically it tells you what happens as you go out. This is the cubed row. These are the coefficients that I get. I can definitely go into more detail on that if you're confused on it, but basically what ends up happening when I cube this is I get x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. Then I have this minus delta x minus x, so minus x minus delta x. Then I have this minus x cubed plus x. Minus x cubed here, plus x cubed here are equal and opposite, plus x minus x are equal and opposite. This is all still over delta x. So on top, I can factor out a delta x here, 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 and here. When I do that, it becomes the limit as delta x approaches 0 of delta x factored out, 3x squared plus 3x delta x plus delta x squared, used to be cubed, took out 1 to bring it down to squared, minus 1 all over delta x. This delta x that we pulled out and this delta x on bottom can be reduced, which leaves me with the limit as delta x approaches 0 of 3x squared plus 3x delta x plus delta x squared minus 1. When I plug in a 0 anywhere where I see a delta x still left in the problem, this term is going to become 0, this term is going to become 0. What's left is this term, which had no delta x's in it, 3x squared, and this term, which had no delta x's in it, minus 1. So my final answer to this problem is 3x squared minus 1. Number 6 asked me to start with 1 over x plus 1. What's going to happen when I plug in f of x plus delta x is it's going to become 1 over x plus delta x plus 1. The problem is when I go to subtract these two things, I won't have a common denominator, so my common denominator is going to need to be found by multiplying f of x by the bottom of this fraction, x plus delta x plus 1, and this fraction is going to need to be multiplied by the bottom of this fraction, x plus 1. So when I do that, it lets me have the limit as delta x approaches 0 of f of x plus delta x, which is this, and I'm going to put it in its common denominator form. So it's going to become x plus 1 over x plus delta x plus 1 times x plus 1. From that, I'm going to subtract f of x, which when I multiply out like this, becomes x plus delta x plus 1 over x plus delta x plus 1 times x plus 1. This is all still over delta x. So this is f of x plus delta x, which we've put in common denominator form. This is f of x, which we've put in common denominator form. Since they both have the same denominator, we can combine the tops. It's going to become the limit as delta x approaches 0 of on top x plus 1 minus, if I distribute this negative sign, minus goes to that x, minus goes to this delta x, minus goes to this 1. Over on the top, still this common denominator, x plus delta x plus 1 times x plus 1, and over this delta x. On top here, what's going to happen is this positive x, this negative x can go away. This negative 1, this positive 1 can go away. So I really have negative delta x over this being divided by delta x. Being divided by that is like multiplying by the reciprocal, or like multiplying by 1 over delta x. So really I can write this as times 1 over delta x, which gets rid of this delta x here, gets rid of this delta x here, and just changes this to a negative 1. So my problem continues as the limit as delta x approaches 0 of What I have now on top is just this -1. What I have still on bottom is x plus 1, or I'm sorry, x plus delta x plus 1 times x plus 1. I'm now at a point where I can put in a 0 anywhere where I see a delta x. The 0 goes in here, and this becomes -1 over x plus 0 plus 1 times x plus 1, which is really -1 over x plus 1 times x plus 1, which I'm going to write as x plus 1 quantity squared. When we start with something that has a fraction on bottom, I like to write out and find common denominators for the f of x plus delta x before I begin the limit process. So I'm going to write here f of x plus delta x. In this case, that would be 3 divided by x plus delta x quantity squared. So in order to get this common denominator, we're going to have to multiply this one by this bottom, this one by this bottom. So we're going to have to multiply this equation by x plus delta x quantity squared over x plus delta x quantity squared. This one we're going to have to multiply by x squared over x squared. So when we start our limit process, it's going to become the limit as delta x approaches 0 of, we're going to do f of x plus delta x minus f of x. So 3x squared over x plus delta x squared times x squared. From that, we're going to subtract f of x, which is 3 times this whole thing, which we found previously to be x squared plus 2x delta x plus delta x squared, all over x plus delta x quantity squared. I'm sorry, this squared here is in the wrong spot. It should be outside the parenthesis there, apologies, times x squared. All of this is over delta x. So now that we've got a common denominator, we can multiply out, see what happens from here. Basically, this 3x squared and this negative 3x squared are going to cancel each other out, leaving behind this negative times everything else in there, still over that common denominator. So this becomes limit as delta x approaches 0 of, again, 3x squared minus 3x squared goes away, but I still have -3 times this 2x delta x, which becomes -6x delta x, -3 times delta x squared, which becomes -3 delta x squared. This is all being divided still by x plus delta x quantity squared times x squared all over delta x. We're going to do that same trick where we multiply by 1 over delta x, and really we're going to factor a delta x out of the top as we do that. So it's going to become the limit as delta x approaches 0. What's going to end up happening on top is I'm going to have delta x factored out and leave behind a -6x minus 3 delta x. It's still all going to be over x plus delta x quantity squared times x squared, but now going to be multiplied by 1 over delta x. And again, that came from dividing by delta x. I can multiply by the reciprocal. So this delta x here and this delta x here are going to cancel, which means I'm going to be left with the limit as delta x approaches 0 of -6x minus 3 delta x over x plus delta x quantity squared times x squared. When I plug in a 0 everywhere where I see a delta x, This term goes to 0. The top is just negative 6x. On bottom, this zeroes out where I have this delta x, and I only have x on the inside, so it becomes x to the second power. So it's x to the second power here, another x to the second power next to it, and a negative 6x on top. What I can do is reduce one of these x's, so this x on top, one of these x's on bottom, and then combine exponents. So you can see it either as the 2 times the 2 gives me x to the 4th on bottom, reduced by 1, it gives me x to the 3rd. Or the x on top, the x squared on bottom, reduces to single x to the 1st power on bottom, times x to the 2nd, lands me at x to the 3rd. No matter how I get there, there's a negative 6 that's left on top, and an x to the 3rd that's left on bottom. Last one in this section is asking me to do the root of x, which is a little more complicated than it looks, because in order to do this subtraction, I'm going to have to use conjugates, I believe. So here I'm going to start out by saying the limit as delta x approaches 0, and I'm going to have f of x plus delta x, which is the root of x plus delta x, minus f of x, which is the root of x, all over delta x. So if I put in 0 here, I'll get 0 over 0. I've got to do something to make it not that. The way that I'm going to do it is multiplying by the conjugate. So multiplying by the conjugate means take how it is on top, multiply by the same exact thing except the opposite sign here. So I'm going to multiply by the root of x plus delta x plus the root of x. On bottom, I have to multiply by the same thing that I did on top, the root of x plus delta x plus root of x. What's going to happen is this times this comes out of the square root sign and just gives me x plus delta x. This times this comes out of the square root sign and gives me minus x. The beauty of multiplying by the conjugate is this negative root x times this positive root x plus delta x, and this positive root x times this positive root x plus delta x get rid of the middle term. So the middle term cancels each other out. There's a negative version and a positive version that are exactly opposite and equal. So this came out of the root, this one comes out but negative, and it's still, I should have my limit here, so it's still equal to the limit as delta x approaches 0 of now x plus delta x minus x over delta x times root of x plus delta x plus root of x. So we still have things under the root and everything that is messy that stayed on bottom, but the good news is the top reduces. The top reduces because this positive x and this negative x are equal and opposite, and then this delta x, the only thing that's left behind, I can reduce with the delta x on bottom. So it becomes delta x approaches 0. This and this are equal and opposite and just leave me with the delta x on top. On bottom, I've got that same delta x that's factored out and can be reduced, which leaves me only with the root of x plus delta x plus root of x. On top, a 1's left behind. So if I plug in 0 everywhere where I see a delta x, this becomes 1 over the root of x plus 0 plus the root of x. Well, the root of x plus 0 is just the root of x. So the 1 stays on top, but 1 roots of x plus 1 roots of x gives me a total of 2 roots of x. So my final answer is 1 over 2 root x.